Now we're going to solve a radical inequality. And the first steps are about the same, are pretty much the same. It's at the end that we are going to approach this differently. Our rules are the same. We want to isolate the most complex root, and in this case, that would be 3x minus 6. We're going to subtract 4, and we get 3x minus 6 less than or equal to 3. We can then undo the square root by squaring, and that will give us 3x minus 6 less than or equal to 9. We will add 6 to both sides. We get 3x minus, or less than or equal to, 15 divided by 3, and x is less than or equal to 5. Now, in the other questions, when it was not an inequality, we would have stopped at this point and checked our answer. Because it's an inequality, we're going to actually check zones, and I'll show what that means in a moment. But first, as with any other inequality, we would have an answer on a number line. That's one way to represent the answer. And I'm going to put a point at 5. Okay. And then we're going to do the next step. This is called a critical point. There's another critical point in this particular example, and that is this. In other words, we can find it by using that. If we have a negative inside that square root, that'll involve imaginary numbers. And we want to avoid that right now. We want to keep our x values to have, or make our x values have values in which whatever we plug into that inequality, the absolute value is guaranteed to be the absolute value of a positive number. In other words, we are going to take what's inside the square root and ask ourselves, how can we guarantee that 3x minus 6 inside that square root will always be greater than or equal to 0, thus keeping us from having to involve negative numbers in there, in other words, i's, or imaginary numbers. So this inequality will help us decide what x values will guarantee that we get a positive number. So we would solve for x. And we get 2. So this is going to be our other critical point. So solving it gave us one critical point. Using our radical and focusing on that piece of what is inside the radical allows us to get the other critical point. Now, when we have 2 points on a line, we have created 3 zones. We have this zone that we're going to check, this zone that we will check, and this zone that we will check. So we need to pick a number in those zones and check and see if they work. An easy number in this case would be, in the left side of 2 would be 0. Then let's try 3, for lack of a better number, and 6. So let's try those numbers. If we check those, we get 3 times 0 minus 6 plus 4 is less than or equal to 7. 3 times 0 is 0 minus 6 gives us the square root of a negative 6 plus 4 less than or equal to 7. Well, here we have an imaginary number already, so that's not going to work for us. So try another one. Try the 3. 3 times 3 minus 6 plus 4 less than or equal to 7. 3 times 3 is 9. 9 minus 6 is 3. Now the square root of 3 is 1 point something. .73. So in other words, 1.73 plus 4 will be less than or equal to 7. This is true. And this one was false. So that zone works. So now let's check the 6, because that might work also. 3 times 6 minus 6 plus 4 less than or equal to 7. 3 times 6 is 18. 18 minus 6 is 12. The square root of 12 is 3.46. And that is greater than 7, not less than or equal to 7. So that is not true. So that zone is out. So our answer will be 2 to 5, including 2 and 5. So we need to remember some important things with this. We go about solving it like we would an equation, but our answer is not just the answer, and that's the only one we'll get. It will be a critical point. Then we go to the radicals. Look specifically at what's in the radical and ask yourself, how can I guarantee that it will be greater than or equal to 0? And solve for x. That is our second critical point. Once you plot them on a number line, check numbers from each zone and see if or what zone will be considered acceptable, and then graph those zones.